Hey guys, today I wanted to talk about asymptotes. So, as you noticed last class, tangent and cotangent functions always have vertical asymptotes and they repeat. There's actually an infinite amount of them. If we kept graphing to the right and to the left, every period there's another asymptote. Okay, so what you're going to be asked on a quiz is for like a generic formula for all of the asymptotes, and we're going to go over how to write that. I went over it briefly in the video that you watched last class. I wanted to get a little more in depth into asymptotes today. So the first thing I wanted to go over is why are there asymptotes? Okay, so the first thing I want you to remember is that tangent equals sine divided by cosine. And therefore, since cotan is the reciprocal of tangent, that equals cos divided by sine. So a vertical asymptote, so let's take a look at this one right here. Pi over 2 on the tan graph. Okay, a vertical asymptote, what it is an x value that is not allowed. So if you look there, if I look at this line, these are vertical lines where every x value is the same. The first one here, they're all pi over 2. This one here, they're 3 pi over 2, etc. So the x value is always the same. That means that that x value is not allowed. That's why there's an asymptote there. And the reason that an x value would not be allowed would be that it makes a denominator 0. Okay, so why would the denominator be 0? Tan is sine divided by cos, so tangent is going to have an asymptote wherever the cosine of that angle is 0. Cotangent will have an asymptote wherever the sine of that angle is 0. Okay, if you have a 0 in the denominator, it's undefined, and that's where your asymptotes occur. All right, so now looking at our unit circle, taking it one step further, if you recall from when we did our unit circle plate in class, cosine represents the x values, sine represents the y. And again, the unit circle is centered at the origin 0, 0 with a radius of 1. So for example, this first point out to the right is at 1, 0. That represents the cosine and the sine of that angle. So since this angle here is 0 degrees, the cosine of 0 is 1, the sine of 0 is 0, etc. So if tangent, right, tangent has an asymptote wherever cosine is 0, and cosine is the x. Okay, so I see an x value of 0 at 90 and 270. Or in radians, that's pi over 2 and 3 pi over 2. And if I go to my tangent graph, pi over 2, 3 pi over 2. All right, now cotangent. Cotangent is undefined whenever sine is equal to 0. Sine is the y value. I see y values of 0 at 0 and at 180 or at pi. And then when I go to my cotangent graph, an asymptote at 0, the next one over is at pi. So basically, that's why for tangent, the first asymptote is at pi over 2, because that's the first place where the x value or the cosine is 0. And then for cotangent, 0 is the first asymptote because that's the first place that the y value is 0. Okay, so that's kind of like why there are asymptotes. Okay, that's why certain x values just aren't allowed. Okay, now I'm going to get into basically how to find and how to write your asymptotes. So first, when you are asked on a quiz for your asymptotes, always write them in this pattern. It's the first one plus or minus period times k. All right, so I'll get into more of what that means, but this is like the generic formula that represents all of the asymptotes. So first I'm going to do tangent because tan is a little harder. And then once we get to cotangent, you'll see that that's a little easier. And I'm really just focusing on asymptotes here because the last video went into everything else. Okay, so if I was graphing this, okay, my A value is 2. Period, remember, for tan and cotan, it's pi over b, not 2 pi over b. So it's pi over 4. So my DCV is pi over 4 divided by 4, which is pi over 16. Okay, asymptotes, first, for tangent, you should do it after you graph. So graph first, then write the formula for the asymptotes. Okay, the reason being graphing it for tangent is actually going to help you figure out this, the way that we write it. So here's 0. And I'm not going to graph this whole thing because all I care about right now is asymptotes. Okay, so I'm going to go 1 DCV over is pi over 16. 2 DCVs over, 2 pi over 16 is pi over 8. 3 pi over 16, 4 pi over 16 is our period, pi over 4. Yeah, I'll do the same thing negative. So, graphing tangent, the starting point, the first point for tangent is on the midline or the axis of the wave. Okay, so here there's no number being added to the end. So my axis of the wave is at 0. Okay, so in this case, my starting point is at the origin 0, 0. If the midline, like let's say there was a +3 here, the midline was at 3, my starting point would be up at 3. Okay, but for this one, the midline's at 0, so that's your starting point. Okay, positive tangent, the next DCV to the right, I'm going up by my A value, which was 2. So I'll go up 1, 2. The next one over is an asymptote. Okay, now I'm going to go to the left. I just want to create one period here in the middle. Next DCV over, now I have to go down by A, and then 2 away is an asymptote. Okay, now these 3 have to connect to create our curve. Approach your asymptotes in both directions without touching it. Okay, so this is the general way you're going to create a tangent graph every time. Okay, the key is your first asymptote, the first one to the right, or really even to the left, is 2 DCVs away. Okay, that's the key. So you always scale your x-axis by the DCV. So from 0, if I go 2 to the right, there will be an asymptote, and 2 to the left, there's an asymptote. Okay, basically asymptotes are 4 DCVs apart because they're a full period apart, and every 4 DCVs equals a period. So when you start on tangent, your starting point is right in the middle of 2 asymptotes. So you go 2 to the right, 2 to the left, and there are asymptotes there. Okay, so now the formula for the asymptotes. Okay, this is what you would write on your quiz or test. The first one, meaning the first positive one, is here at pi over 8. Plus or minus the period times k. The period we said is pi over 4 times k. And what k represents is k can be any integer, any whole number. So basically, this little equation here represents all asymptotes. Okay, so it has the first one, pi over 8. Plus or minus means that there are some asymptotes to the right of pi over 8, some to the left. And then plus or minus pi over 4 times k. So your period is pi over 4. And k, it could be 1, 2, 3, 4. So if you add 1 period, you land on another asymptote. 2 periods. So whatever whole number you plug in for k, basically there are an infinite number of asymptotes if you keep going right and left, and that's what k is for. Okay, so one more time. It's the first one plus or minus the period times k. All right, and what I'm going to add to that here is the first one is 2 DCVs away from 0. Okay, now cotangent. Okay, and this one's a little easier, so I'm going to go through it quicker. I'm not actually going to go through this entire graph, but okay, so this one has a midline at 2. Okay, so you could draw that in if you'd like. My period pi over 2, because b is 2, dCV, divide that by 4. So dCV is pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and 4 pi over 8 is pi over 2. Same thing, negative. Okay, so what's different about cotangent and why cotangent is easier is that the first asymptote is always at 0. Okay, so very simply, the first one is always there at 0. So, and I forgot to put here a equals 3. So for this one, the first one, always 0, plus or minus, period times k. The period we put right here was pi over 2. So pi over 2 times k. Okay, and what that means is the first one's at 0. Then if you remember, asymptotes are always 4 dCVs apart. So 1, 2, 3, 4 apart. I got another one at pi over 2. And then 4 to the left, I have one at negative pi over 2. Okay, now in between the asymptotes, right in the middle, I would have a point on the midline. Okay, now cotangent, positive cotangent looks like the opposite of positive tangent, or it looks like negative tangent. So to the left, I'm going up by 1, 2, 3, because that's my A value. And to the right, down 1, 2, 3. Okay, so basically, the asymptotes, you represent all of them because of this plus or minus here and because of k, which means you can go right and left with them and you can go on forever in both directions and you'll keep repeating every 4 dCVs there'll be an asymptote. What makes tangent harder is that you have to figure out what the first asymptote is, okay? And that will always be 2 dCVs away from 0, okay? So it's not always the same value because your dCV is not always the same. But whatever your dCV is, that second one, in this case, pi over 8, is where your first asymptote is. And then it's always plus or minus your period times k. For cotangent, it is slightly easier because it doesn't matter what the period is or what your dCV is, the first asymptote will always be at 0. Okay, now if we had a phase shift, that would move that, but we are not going to do any phase shifts with tangent and cotangent. So all you need to know is that cotangent always starts at 0. I remember it like this. I write the little 0. Cotangent's first asymptote is always at 0. Okay, tangent is a little harder because you have to figure out the first one. But it's not too difficult because the first asymptote is always just the second dCV away. All right, guys, I hope this clarified some of your questions about asymptotes. Please don't hesitate to reach out if you have any questions. Have a great day.